So let's talk about these examples from the section about understanding the federal budget. So on this example 3, it says a federal debit end of 2013 was approximately 17 trillion. This debit was divided evenly among my apologies, guys, roughly around 315 million citizens of the United States. How much would you owe? So we are talking about some big old numbers. If I watch 17 trillion in notation that we understand, this is what we'd get. That's 17 trillion. So what I want to do is write it in a shorthand that we can understand. Now, I could leave it as 17 if the trillion was on both these numbers, or if million was on both, but they're not the same unit, so we need to write it in a format. So what I'm going to do is write it in scientific notation. And in scientific notation, with the number in front of the decimal must be 1 to 9. It cannot be 10 or 11 or 0. So what I'm going to do is I'm going to move the decimal. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's write this as 1.7 times 10 to the positive 13 power, because this is a big number. If it was a little number, we'd write it to a negative. All right, so this represents the 17 trillion. Now let's write the 315 million in its correct notations. So I'm counting out my zeros. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. All right. So now I have, this one is going to be 3.15 times 10 to the 8th. All right. If you notice that we are dividing, because it asks you to divide, and I'm going to have the debt ratio per person, or per so many people, right? Or citizens. So now what I have 1.7 divided by 3.15 times 10. And whenever you're dividing by like bases, you agree the 10 over 10 is like bases. They're raised to a power. We take the top power minus the bottom power. And let's divide this out. I'm doing a little bit of basic math, not saying you have to go this far with it. All right, so we have 1.7 divided by 3.15. That gives me this decimal number. So I'm gonna just go ahead and write it like this. This is not my correct answer yet, okay? Because this is not correct notation. And that's times 10 to the 5th power, right? All right, so now let's talk about this. This is not how we'll write our final answer. You could type this whole thing in your calculator. It would give it to you. But this one here says we're going to move the decimal 1, 2, 3, 4, 5. And it's going to give us a number, right? We're going to round to the nearest whole person. And we're going to round to the nearest thousands. So that means we have $54,000 dollars per person. Just make sure and read if it wants you to round or not. That gave me 53,968, and I rounded to the nearest thousand, so that means it looked at the 9. Okay. The next one says economists also commonly consider deficit and debit numbers as percentage of gross domestic product. So GDP for 2012, the GDP was 15.6 trillion, and the total deficit was 1.1 trillion. And the end of the year debit was 16.1 trillion. So we're going to find the deficit and the debit as percentage of GDP. So we got some work to do. First things first, I'm going to divide. Let me get some information for you. This is my first one I want to do. So I'm going to take the total deficit divided by the GDP. And I'm gonna multiply it to 100% because I'm gonna put it in percent. So what do I have? I got 1.1 trillion divided by the 15.6 trillion. And if you notice, I didn't have to make no changes to this notation because they're both in trillion. We're going to multiply it by 100%. And I get, and I'm going to round to the nearest tenth, 7.1, approximately 7.1%. All right, now let's find the debit as percent. I put an I there. There we go. So I'm going to take the total debit divided by the GDP times 100%. So I got 16.1 trillion divided by the 15.6 trillion times 100%. And I'm going to round to the nearest whole number. And I got 103. So 7.1, 103. There we go. So both values are high relative to historical averages, but not by nearly as much as the actual dollar numbers suggest. Okay, so let's move on. Take a minute to read that. Let's move to this next example. Says for 2012, the interest on the debit total of 360 billion and total debit at the time was about 16 trillion. What was the annual interest rate paid by the government? So we need to write these in a format that is doable. So either they need to be both trillion or both million. So what do I know? I know for every 1 trillion, that is equal to 1,000 billion. All right, so knowing that, I can rewrite this as 360 billion over 16,000 billion. And now let's divide it out. I get this. And let's multiply it by 100%, or you can just move the decimal 2 places to the right, and we get 2.3%. Okay, so let's move to B. So that answers that question. What was the annual interest rate paid by the government? It's 2.3%. Suppose that the interest rates paid by the government had been at their historical average of about 3%. How would that affect, have it affected the interest payment? Okay, so if the interest rate had instead been 3%, the interest payment would have been 0.03%, 6 times at 16 billion, which would have gave me. So let's just write that out. So I would write that in decimal. We would multiply that by the 16,000 billion. And that would have gave me $480 billion. All right, this $480 billion, if I take it and subtract the, right here, this 360 billion, I'm going to get $120 billion. Okay, so this is more than the actual percent payment. So notice the interest payment of 360 billion was already more than double what the government spent on all education, training, and social services combined, and about 20 times what it spent on NASA. The extra 120 billion that would have been needed at a historical average interest rate would have made the budget picture far worse. So that was just some information. So take a minute to read this. Screenshot it. Read this. And now let's do the next example. The next one says the federal government ran a 1.089 trillion, which is 1,089 billion, unified deficit in 2012. However, the government also collected 62 billion more in Social Security revenue than it paid out in Social Security benefits. So what is the excess 62 billion of Social Security revenue called? So we're going to take, we're going to take the unified. Net income. And I'm going to subtract and the off budget. Net. Oops. Income. And it's going to equal the on budget net income. I'm going to abbreviate net income. Okay, so now let's do this. So we have a negative 1,089 billion minus the 62 billion gives me a negative 1,151 billion. So the amount by which the government actually overspent in 2012 was the budget deficit of 1,150. So what happened to the excessive revenue? We're in the red, right? So moreover, because the government, other trust funds and other accounting details, the gross debit rose by even more than this amount. So this is like crazy. It's crazy. Okay, let's move on. And I say crazy, it's just the numbers, we're in the red, 1,150 billion. And if these numbers are accurate, then that was what was spent. And if the Social Security, if the government's getting more in on Social Security than they're paying out in benefits, then there's no reason to be in the negative. But that's just an opinion. And these numbers, they're not up to date. And it's just information pulled from a textbook. So these numbers can be varied. However, this is how to calculate it. Example 7 says in 2012, individual income tax made up about 47% of total government receipts of 2.45 trillion. Suppose the government needed to raise an additional 600 billion through individual income tax. How much would taxes have to increase? So individuals' income taxes accounted for 47%. That's what we got here of this 2.45 trillion. Or we can write this here as turn this into decimal and multiply it by the 2.45. And you could write the trillion in there because in the notation we do need it 0.47 times 2.45. We get 1.1515 trillion. Just watch on the rounding. I'm going to round to the nearest hundreds. In government revenue. And raising the additional 600 billion. So I can take this 600 billion dollars. And if I wanted to write it in trillion, I know I divide it by 1,000. And I get this 0.6 trillion. And the reason why I know I divide it by 1,000 is because we know for every 1 trillion, it's 1,000 billion. Okay, now doing that, I'm going to take this 1.15 trillion I'm gonna add it to the 0.6 trillion, which gives me 1.75 trillion. Oops. I'm gonna hit this sidebar over here. All right, so now we have that number. So what I need to do is in percentage terms, the amount represents a tax increase of, we got new value minus the old value, all divided by the old value. So what is the new value? It's that 1.75 trillion. I'm going to subtract it by the old value, which is 1.15 trillion, all divided by 1.15 trillion. And at the end, we're going to multiply by 100%. So let's do that. 1.75 minus 1.15 divided by 1.15 times 100. We get, and let's round to the nearest whole number, so I get 52%. I'm going to use my approximation sign. So on average, everyone's income taxes would have to increase by 50% in order to generate this additional revenue.